Hello. So in this lesson, we are going to be looking at transformations, what a transformation is, and the different types of transformations. So before we begin, make sure you put your name on your paper. My name is Mrs. Pierce. So that's what I'm going to put there. And then make sure you also put the hour and the date of you're taking these notes. So to start with, what is a transformation? A transformation is basically any change. Be nice if I could spell right. Any change to a figure. So that could be its location. It could also be the size of it, the shape. I'll say or shape. That looks horrible. Or shape. All right, so a transformation again is any change to a figure or graph, location, like the location, size, or shape. So there are a few different types of transformations. There are translations, reflections, stretches, and shrinks or compressions. So that we're going to focus on. So translation, you've probably heard of just called a shift or maybe a slide. And basically, it's moving the figure to the left or the right, up or down. Now, if you are moving or translating or shifting the graph left or right, it's called a horizontal translation. If you are moving the graph or translating or shifting the graph up or down, that is called a vertical translation. So inside of the translation, there are actually two types of translations, horizontal and vertical. Horizontal goes left and right, vertical goes up and down. The next type of transformation is the reflection. So a lot of students just call it a flip, but basically the graph or the figure flips over. So flip the figure or graph over a line. Now we are going to be focusing on the X and Y axis. So primarily the X axis and or Y axis. Now, one thing I forgot to mention with the translation and also with reflection is that when you do a translation or when you do a reflection, this does not change the shape or the size of the figure. So going back to the translations, again, I would write that in. There's no change to the shape, size, or shape. Now, when we get to the stretches and the shrinks or compressions, now you will see some movement or change to the shape. So a stretch is basically when the figure or the graph gets pulled, so the points pulls away from the axis. And again, there are two different types of stretches that we're going to be looking at, horizontal and vertical. So it is now, again, going back to the changing the size and shape, this does change the shape of the figure. So a vertical stretch, the points pull away from put parentheses, points pull away from or get farther away from the x-axis. So that can get a little confusing because it's a vertical stretch, but when you're stretching things vertically, they're getting farther away from the x-axis. And then your horizontal stretch, the points are going to pull away from, or the points move farther away from the y-axis. So again, that gets a little confusing because it's horizontal, but the points are getting farther away from the y-axis, not the x-axis. All right, so we also have the stretch or the shrink. The shrink or the compression. So the shrink or the compression basically means that the figure or graph gets closer to the axis. Again, it depends on which one you're talking about. Again, it does change the shape. Or size. And again, we have two types of compressions or shrinks. Extend this over here. A vertical, I'll just call it a shrink because it's shorter. The points get closer to the x-axis. So again, confusing because it's vertical and it's getting closer to the x-axis, but that's what it does. And a horizontal shrink means that the points are getting closer to the y-axis. Now I'm going to show you some of this on that Desmos graph in a minute, but we're going to finish taking our notes here first before we play around with that. All right, so the equation, when you're writing equations or playing around with these equations, there is what I call it the general transformed equation. Again, this is in function notation, so the f represents whatever the starting function is. So y equals f of x. I've got this little note here that y equals f of x is your starting function. Now that could be a quadratic function, a square root function, absolute value function, lots of different types of functions. But the general function notation looks similar to this. So if we have an a value, we're going to talk about a first. So a is the number that's being multiplied in front of or multiplied to the function. Most of the time it's in front of. So if you look at the starting function, there's nothing in front. So what number could you multiply times anything to equal itself? 1. So the parent function or the starting function has an a value of 1. So that doesn't make any changes. But what if the a, instead of being positive 1, was negative 1? So if a is negative, and we're just going to say negative, then you have a reflection over the x-axis. Now I'm writing way over here because I know I've got to define and explain what A, B, H, and K do to the graph. So starting out with A, make this blue or something. I don't like that. Okay, so if A is a negative number, then there's going to be a reflection over the x-axis. So that's one thing that A can do. There are two other things that A can do. A can be if, well, I'm writing differently this time. If the absolute value of A is greater than 1. So think about multiplying a number that's greater than 1. Well, that's going to make something get bigger. So if the absolute value of A is greater than 1, then it is going to make the graph stretch vertically. So we call it a vertical stretch. By a factor of whatever the absolute value of A is. So we're looking at the absolute value, which means we're disregarding whether it's positive or negative, because if it's negative, that's going to be reflection. But if it's a -5, it's going to be a vertical stretch by a factor of 5, not -5. So we'll see that more when we get into more examples. Okay, the third thing to talk about A is if the absolute value of A is between 0 and 1. So that's between. So what kind of numbers are between 0 and 1? Numbers like a half or a third. So if you're multiplying something by a half, you're taking half of the value it originally was. So this is going to be a vertical shrink or compression by a factor of whatever that absolute value of A is. Okay, so the last thing that I would like to talk about is which coordinates it affects. So when you have something on the outside that's being multiplied, so the outside of the function rather than inside parentheses with the x, it's going to affect the y coordinates. So that's very important that you understand that it's going to affect the y coordinates. All right, so that takes care of A. Moving on now to B. So B is going to basically do the exact same thing as A did, but instead of it affecting the y coordinates, it's now going to affect the x coordinates because it's on the inside of the parentheses with the x. And it's going to be basically you're multiplying by the reciprocal of this B value. That's why we have it as 1 over B. So 3 things that it can do. Again, we're going to say it affects the x coordinate. So remember, inside affects the x coordinates, outside affects the y coordinates. So one thing that B can do, if the value of B is negative, that means you're going to have a reflection over the y-axis. So yes, it affects the x coordinates, but it's a reflection over the y-axis. The second thing that B can do, if the absolute value of B is greater than 1, kind of like here, when the absolute value of A was greater than 1, then you have a horizontal stretch. So you have a horizontal stretch by a factor of whatever the absolute value of B is. And we say factor because it's being multiplied, but notice in the equation, it's being multiplied by the reciprocal of B. So in the equation, the number here is going to be the reciprocal of B. So if you see a 1/2 here, the value of B is actually 2, not 1/2. So that gets a little confusing, kind of like the H is going to be opposite here in a minute. The third thing that B is also responsible for, if the absolute value of b is between 0 and 1, then it's going to be a horizontal shrink by a factor of, again, it's the absolute value of b. So if we think about a value that's between 0 and 1, like 1/2, if you were dividing or taking the or dividing 1 by 1/2, it's actually going to be the reciprocal of 1/2, which ends up being 2. So if you saw a 2 in the parentheses being multiplied to the x inside, then it would actually be a horizontal shrink by a factor of whatever that absolute value of b is. So that takes care of the b value and what it does. The next thing we have is h and k. So when you have a number in parentheses with the x being added or subtracted, that is going to affect the graph horizontally again. So it affects the x coordinates. And again, think inside. So if it's in parentheses with the x, it's going to affect the x coordinate. So you have basically if h is a positive number, then you're going to have a horizontal translation h units to the right. However, in the equation, in parentheses, it's always x minus or x and then the opposite of h. So if h is a positive number, you're always going to see it's in your equation, it's going to say x minus h. Horizontal. So horizontal translation, h units to the right, but remember your 8 in your equation, it's going to be opposite. The second thing, it can make the graph shift or move to the left, again, without changing the size. So if h is a negative number, then we have a horizontal translation Now this time we're going to say absolute value of h units left, because you're not going to say that it moves -3 units left. You're going to say it moves 3 units to the left. So the left takes care of the negative when you're describing. Again, now in the equation, even though h is a negative number, let's say negative number. So if h is a negative number in your equation, if you are subtracting a negative number, your equation is going to have a plus in here. So keep that in mind when we start looking at more equations. All right, so the last one that we have to define here is our k. Use orange. So your k is responsible for your vertical translations up or down. It is going to affect the y coordinates. Again, things that are on the outside of the parentheses. So the a gets multiplied, it's on the outside. K is being added or subtracted on the outside. It's going to affect the y coordinates. If k equals a positive number, or k is a positive number, then it's going to be a vertical translation up k units. So vertical translation up k units, or k units up. That's another way of saying it. If, however, k is a negative number, then it's going to be a vertical translation. Absolute value of k now, because we don't want to say negative 3 units to the left. We want to say 3 units to the left. So units are not left, down. So it's going to be a translation, absolute value of k units down. Now, what you'll notice that I talk about inside is opposite, outside is the same. So when you multiply that a, you're not taking the reciprocal of it. This number that is in front, 1 over b, is the reciprocal of b. H is the opposite of h. So in your equation, it's going to be the opposite. But k, you're adding k. So if you're adding a number, that's not going to change the sign. Only if you're subtracting will that change the sign. All right, so that takes care of the notes part. So now we're going to go back to the Desmos and kind of take a look at some of those different transformations. So here I have a parabola, and I've set it up so that we've got our h and our k that we're looking at. So if I start with my k, so the k is responsible for the vertical translations up or down. So if I have a positive k value and I move that k up, you'll see that the graph is also going up that many units. So here I'll stop if k is 4, you can see the graph went up 4 spaces. But I will take it back down to 0 so we can look at the horizontal. So the horizontal translation is we use h to represent those. Again, if it's a positive h value, so h is 1 or 2 or 3. So looking at the graph here, it's going to the right. But in your equation, we have a minus. So be very careful with that. The sign has to be opposite in the equation than it is the actual value of h is the opposite of what is in the equation. All right, so if we go back to the negative side and we make h a negative 4 or a negative 5, you can see that it's moving to the left now instead of the right. But in your equation, if you're subtracting a negative 5, then that's going to make it a positive 5 in your equation. All right, so I'm going to take that back to 0, so make it the same as the parent function. So when h and k are 0, you have your starting function has not made any changes horizontally or vertically. Okay, in the next graph here, I have an absolute value, and I'm going to show you the vertical and horizontal stretches and shrinks. So if I want my parent, which is the red one here, let me actually change that to purple. I like it to be purple for the parent. All right, so the parent is purple. The transformed function is the orange. So if A is being multiplied and B is the reciprocal of this number here, in order to make this the same as the parent, you want your A and B values to be 1. So I'm going to move this back to 1. So now you can see the graphs line up, because when you multiply by 1 or you divide by 1, you're not making any changes to the graph. So that's why we call this by a factor of, because we're multiplying or dividing. So here, if I take my A value and make it 2, and if I look at my graph, so the original point here had a y coordinate of 1. Now it's at 2. This point here originally had a y coordinate of 2, but now it's moved up to 4. So the points are moving farther away from the x-axis, but not at the same rate. It's by a ratio, or I guess not by the same value. They're not moving up by the same value. They're moving up by the same rate or ratio. So if we take 1 and double it, we get 2. So this point, even though it's only moving up 1 point, 1 value, you're doubling the y coordinate. This point has a y value of 2, so it does move up to 4. It doesn't just move up 1 like in a translation. All of the points would move up the same amount. But since this point is going up 1 and this point is going up 2, you can see that they're not the same, so it's by a rate or a scale. So you're doubling the y coordinates. So let's do one more here. If I go to 3, now I'm taking those y coordinates and tripling them. So instead of my y coordinate here being -1, now it's at -3. So it's getting farther away from, the points are moving farther away from the x-axis. And you'll notice the graph also is getting narrower. If I look at another point here, this point had a y coordinate of 2. If I multiply that by 3, I now have a y coordinate of 6. So you're tripling the y coordinate or multiplying it by 3. All right, so to make this go back to lining up with the parent function, I've got to take this back to 1. Now let's focus on the vertical shrinks. So we looked at values that were bigger than 1. Now we're going to look at values that are between 0 and 1. So if I say I go to 0.6, well, 0.6 is basically 3/10. So it's a fraction. It's a value between 0 and 1. I wish I would have put a half in there, but it's almost a half. But you can see the parent, again, is purple. So it's the graph is getting closer to the x-axis. And if we look specifically at a point that's 2 spaces away from the x-axis, if this was a 0.5, let me change this actually so that we're stepping 0.1 here. Okay, so, I didn't want to do that. Okay, it's back. All right, so I just changed this so that I could get to 0.5. There we go. All right, so if my a value is between 0 and 1, like 0.5, instead of a point being 1 space away from the x-axis, now it's a half. This point that was 2 spaces away from 2 units away from the x-axis is now 1. This point that was 4 away from the x-axis is now at 2. So it's relative to how far it was to begin with. So the y coordinates are getting smaller, or half of what they originally were. All right. Move it back to 1, and let's talk about the vertical or horizontal. So the b, let's see what b does. So you're dividing b. You're taking 1 divided by b, or the reciprocal of. So this in the equation, you're going to see a fraction when b is bigger than 1. So let's move this to 2. So if b is 2, you actually are going to have 1/2 in your equation. So, but it's not a shrink, it's actually a stretch. If you look at the purple, which is the parent function, and we look horizontally, what's it doing? Well, instead of being 2 units away from the y-axis, so here's your y-axis, we're moving it away from the y-axis. So instead of 2 spaces away from the y-axis, we now are 4 spaces away. And if I were to look at this point that was 4 spaces away from the y-axis, it now is 8 spaces away from the y-axis. So those x-coordinates now are doubling. Instead of an x-coordinate being 2, your new x-coordinate now is 4. Instead of the x-coordinate being 1, like it is here, it now becomes 2. All right, so what if the b value is between 0 and 1? So I'm going to change this. All right, so if I make my b value between 0 and 1, your transformed function is inside of the parent function, so it's narrower. Well, why is that doing that? Because this point, so if I look at this point again, it was 2 spaces, your x-coordinate was 2, so it was 2 spaces away from the y-axis. But now this is only 1 space away. This point that was 4 spaces away from the y-axis is now 2 spaces. So it's getting closer to the y-axis. Same thing on the other side. Instead of 4, it's 2. Instead of 2, it's 1. So they are shrinking. The x coordinates are shrinking. But if you were to divide 1 by 0.5 or divide 1 by a half, you're actually going to see 2 in the equation. So that does get a little confusing. All right, now put this back at 1, and we're going to look at the reflections. So the reflection, I have a square root function here. So for your a value, instead of it being positive 1, if I make it negative 1, you can see that, again, I'm going to change this to purple. Parent should be purple. Okay, so the parent function is the purple one, and then our transformed function is the orange one. And you can see that these points basically flipped over the x-axis. But it's the y coordinates that are changing. So this point right here is the point 1, 1. Now it's at 1, negative 1. So the y coordinate changed to negative 1. If we look at this point here, it's basically you've got 4 for your x coordinate, 2 for your y coordinate. Now, let's see, your y coordinate is negative 2. So instead of positive 2, negative 2. Instead of positive 1, it's negative 1. So the y coordinate, so it's reflecting over the x-axis, and the y coordinate is what's changing. All right, so let's move that back. So now it's lining up with our parent. And this time, let's look at the b value. So if I take my b value and I make it negative 1, you can see that instead of going to the right, it's opening up to the left. So a square root function is kind of like a ray. It has a starting point and then it goes off to the right, or starting point goes off to the left forever and ever. So the parent function, when it's positive 1, goes to the right. If you're reflecting over the y-axis, then you're going to have a negative number here, and it's going to now go to the left. Okay, so one thing I wanted to talk about is the absolute value. Why do we have to say the absolute value? So let me go back to 1 here, and I'm going to go to our a value. So if I have an a value of 2, that's going to be a vertical stretch. We talked about that just a minute ago. So like this point here, instead of 2 spaces away from the x-axis, it's now 4 spaces away. So your y-coordinate changed from 2 to 4. If you have a negative 2, not only, move over. So not only does the graph reflect over the x-axis, but it also stretches. So when it was net positive 2, it was up here. If it's negative 2, it's a reflection and a stretch. So it could involve 2 different things. If it's negative 3, again, you can see it's reflecting because it's flipped over the x-axis, but now instead of like this point, let's go back to this point. This is a good one. If this point has a y coordinate of 2, well, this point down here has a y coordinate of negative 6. So not only is it changing sign, but it's also being multiplied by 3. All right, let's look at the b value. So again, if our b value is negative, it is going to reflect over the x-axis or the y-axis. So here's b value of negative 1. So our parent just moves over the x-axis. Well, if our b value is negative 2, now these points are moving farther away from that y-axis. So it's not the same shape anymore. So not only is it a reflection, but it's also a horizontal stretch. So this point here is 2 spaces away from that y-axis. And originally, it was only 1 space away from the y-axis. All right, so we will see this a lot more coming up. But for today, you need to do your assignment now and play around with these values of A, B, H, and K to try to get your graphs to line up with the dotted line on your assignment.